Hi, everyone. Welcome to the gathering of To Thrive Together Sustainable Living. We're doing this virtually still. One day we will all be back together, and I look forward to that. Tonight we're having a guest speaker talking about building a zero carbon community. Antoni Paleshi is the practice lead of WSP's Canadian Building Performance Analysis team. Antoni's been helping us with the To Thrive Together project on a volunteer basis, and we are so grateful to him for his incredible expertise. He is the project director of the Climate Resilience and Sustainability team and the national lead for zero carbon building. And for us, he is just our human encyclopedia of knowledge about everything building green. And without his expertise, I don't think To Thrive Together would have put together our zero carbon plan in such a practical and attainable way, let's say. As you know, if you have been in other gatherings, or you've been on our website or following along, To Thrive Together Sustainable Living is building a pilot zero carbon multi-generational community in Bloomingdale, Ontario. Our mandate is to change the way we care for both people and the earth. So this project addresses two critical issues facing our culture today. The first is, how do we live on the earth without destroying it when we have an increasing population? The second is, how do we care for people of all ages without destroying their soul? How do we keep thriving and living sustainably on the personal, community, and environmental levels? Without further ado, I'm going to turn it over to Antoni. Thank you so much for being here, Antoni, and thank you for all you do.
Great. I'm sorry for those on the phone. My stories involve a lot of visual discussion. I'm a kind of a data geek, so you'll have to. I apologize if you can't see my screen. I'm going to show you some pictures as I talk. I have like a number of pictures, but I'm going to go quickly through them, and it's more of a coverage of this idea of zero carbon buildings. I'm going to talk a little bit about what carbon means and how it's important to reduce it high level. I'm going to skip over the major motivations. I'm going to talk more about the process, the kinds of decisions that need to be made, and some of the design features of zero carbon buildings. But the goal is to sort of give you a primer of the work that I do and the work that they're trying to do at To Thrive Together in their facility too. So I'll start with a little bit of context. It's always good to have some historic context. So in the 50s, there were 5 days in London in Great Britain where several, about 8,000 people died because of how much smog was released by just coal plants churning out smog. And within 4 years, the UK had developed the first, very notable Clean Air Act, which restricted urban coal use so that people wouldn't suffer as badly from emissions of coal. And there are lots of examples of these. The regulations on the ozone depleting gases are another example where either in jurisdictions or globally, we're starting to try and take action when we realize things. And I call this process, and I don't know if I'm coining this term or if it's like something that's out there in the literature. I call it sort of evolutionary social transformation. So, we kind of understand there's a problem. We conceive of some solutions. Someone has to make a decision on what to do, what policy to implement. Someone has to plan out how to actually enact that policy and what action to take to reduce the smog or whatever. Someone's going to execute it. And then we take a look and we say, did we succeed? And if we need to, we iterate that process. So it's like a very evolutionary, slow change, but meaningful change process. And these last two things are really important. So the observing the results and whether we succeeded and then iterating until we have to achieve hard goals, especially iteration can be very important. And how quickly we need to iterate is also really important. And really, this is just the interconnection of three very important things: science, design or architecture or engineering, or design's kind of a catch-all for people who are coming up with the ideas and how to plan it out and execute those ideas, and governance, the people who make the decisions. And then multiple steps for each of those people to take action on. So, and the same is true. This is a photo from Vancouver. Right now my colleagues in Vancouver are starting to see every summer when the forest fires are burning, they get a kind of smog now. And in many places, the effects of climate change are causing similar impacts to what they saw in those smog days. So I guess I hope that like part of zero carbon buildings and part of the movement and actions that we need to take is that evolutionary social change. We need to wake up, understand that there's a problem, figure out what to do, and then agree that it's worth doing, and then iterate, keep going. Anytime I'm going to break a couple times for questions, but if you have questions and you're like really need to ask a question or you're confused about something, there are a number of graphs that are a bit confusing. I'm going to explain them, but they're not always straightforward. So this is a really important graph. And for those people who like graphs, you maybe have seen this, or if you're into climate change, you might know the story here, but it's a really important one because it helps to explain the problem of climate change in a pretty good, one pretty good image. So the graph is of how much we burn fossil fuels, so natural gas, coal, oil, gasoline, etc. So we call it fossil fuel emissions. This is global emissions, so how much we burn every year. And then each of these lines represents if we continue to burn that amount, like looking forward. So we kind of have one line that shows today. I know, yeah, on the bottom here is time. So if we keep burning more and more and we don't really regulate those, and we let the population grow, and we don't really do anything, we have this scenario here, the pink one. It's kind of a reddish scenario. And that's the scenario. Sometimes people call it the scorched earth scenario, or the worst case for climate change. And that's when all of the ice caps melt, and the big shelves of ice flow into the ocean. New York City is underwater, most of Florida. There's no more Arctic region in this case. So there's the sea ice will mostly be gone in the Arctic. And all of the worst effects of climate change are likely to be realized. So forest fires more frequent, variation in climate impacts very frequent. Now, nowadays, it's not really likely that we will reach this scenario unless there's a complete reversal of global action. So that's a good thing. But we don't really know how far we can go. And so there's these other scenarios here. You can see there's a 6-degree change scenario, 4.5. These are the ones that my colleagues who do resilience planning think about. They say, well, what if it doesn't go right? What if we don't solve these problems? What if we don't iterate? What's going to happen? And that's called climate resilience, thinking about that future climate that we have to worry about. Now, my job isn't that. So I don't worry about these scenarios over here. My job is to help us meet this scenario down here, these two sort of greenish bars. These are called the 2.6 bars, or the 2.6 lines. They're the ones where we actually start to reduce significantly the amount of emissions that we put into the air every year, where we actually start to draw down the carbon out of the atmosphere over a very short period of time. And you might be familiar, this is a graph that is very important. You may know this young lady, her name is Greta Thunberg. She's a sort of champion of this graph. That's a kind of a funny way to put it. She's not, but if you've heard her speak, you've heard her say, just read the science, read what's the problem is, and recognize that we are not taking the necessary action needed to address, to actually achieve the reductions that are needed. And this graph really explains that. What it says is that if we want to have a 67% chance of avoiding runaway climate change, so getting this 1.5 degrees of temperature change across the globe is that magic number. It's in this previous graph here. It's this best case scenario line here. If we want to avoid that, well, then we need to reduce global emissions on a very steep curve over the next 10 years. It can flatten out a little bit more, but we have to get to what's called a net zero global emissions by 2040. So we have essentially 20 years or less than 20 years to do a lot. And even if we want just a 50% chance of staying below that 1.5 degrees, we still have to do all of that by 2050. So we get a 10-year extension if we want to take a higher risk, but you know, it's not that much of a difference. So a lot of needs to change in terms of how we use our energy by now, between now and 2050. And that's, if you've heard, you know, this is a really good article. If you have time to read it, check it out. It's the Atlantic sort of asking this question: why does Greta make adults uncomfortable? And the answer is guilt. She's asking us to recognize something that we are not spending very much time thinking about, and it means it has a risk for her future, right? And it's easy to avoid guilt if you ignore it or try and come up with an explanation for why it's not true, or you look for other reasons for how there could be doubt. But ultimately, that's Greta cuts through that. She says, well, hey, there's science, and people are saying it over and over. It's been known for a long time, and what you are doing is not enough, and that's tough. But let's eat that. Let's do it. Let's realize that there's guilt to be addressed, and let's figure out what we have to do. The good thing is that people have already been thinking about this for a really long time, and this is an article. If you're really interested, you want to learn more, let me know. But these great folks at the Climate Policy Group wrote this article in the Science magazine a while ago, and they basically said, yeah, this is what we have to do. So do the no-brainer things. Let's have a price on greenhouse gas emissions or carbon emissions, that come from burning fossil fuels. Let's not subsidize fossil fuel companies anymore. No more new coal plants. Let's decarbonize everything. So let's have a plan, a first plan, a cut for how to decarbonize cities and major corporations. And there's some discussion about food. We're going to focus on buildings now, but food is just as important or more important. And then beyond 2030, let's have really steeply escalate that price of carbon. Let's make that carbon price a driver. Use economic motivation to make change, really fast change. Let's talk about what carbon neutral buildings or net zero buildings can be, and have a standard that means that they are zero, try and get to zero. And let's think about the life cycle impact. So not just how much energy is used in buildings as they run every day, but what about all the energy to make those buildings and to demolish them at the end of their life? I'm going to talk a little bit about that. And then let's look at all sorts of great ways to start putting carbon into things and having it sit there for a long time. And I'm going to talk about that. It's called sequestration or storage. So these are the high level things that have been identified for a long time. And what these guys showed was that if we do these things and we do them fast and we introduce them everywhere, we can achieve this hard reduction goal. Now, you may know that we have a federal government who is committed to that's called the Paris Agreement, which is to limit temperature to 2 degrees, not the 1.5. So globally, we haven't agreed to 1.5 yet officially, although Canada was a champion in the 1.5 cause. And you probably will hear lots of news this year when everyone goes back to the next conference and tries to maybe get that 1.5 target solidified. So, but Canada was a leader, and they developed a pretty good plan for that initial plan. So again, we're in the sort of policy planning stage, or maybe some policy design. They want to get to at least a 30% reduction by 2030. So not quite 66%, which is what I showed you in the other graph, not nearly what's needed for Greta's standards, but at least the net zero by 2050. So we'll get to that 0 point, by the 50% chance, but at least that, and they plan on releasing more this year from the federal government. So they want to set what's called binding targets, which means they want every 5 years to be held accountable in some way. And they have shown that they're going to start to increase that price of carbon. And you might have seen on your gas bill, there's like a line that says carbon tax or carbon carbon levy, that is that there is a price on carbon right now, and it's transferred to us through how we use natural gas and fuel. For buildings, they want to have a code for new construction that is net zero by 2030, so that's good. They want to have an existing building code to start to make rules for existing buildings. And they want to offer in the short term a lot of loans and incentives to motivate people to make this change, to start to really demonstrate that it's possible and to get that acceleration going beyond just the price of carbon. I just note that, one of the organizations doing the best job of thinking about this is actually the government themselves. They have developed a really impressive, it's called the Green Government Plan, for how to make all the government buildings, so all those buildings occupied by government employees or where there's research or whatever, they're planning to be net zero within their facilities pretty quickly. And it's one of the best plans anywhere, really, especially in Canada. You can learn more about it if you're interested, but they're the ones that, at least the federal government's landlord, is doing a good job. Just so you understand this price of carbon idea and the fact that we're being charged, quote unquote, to emit greenhouse gases by burning things like natural gas and fuel. You can see here the price. I just sort of charted this price over time. The price is kind of low right now. It's $50, and next year it'll be $50. This year it's $40. When I did this slide first time, it was $30. That was in 2020. And with that price, electricity is still 5 times more expensive than natural gas. So electricity is the thing we worry about. It's the thing that has the biggest cost when it comes to using energy. But if we increase that price over time, getting close to what that, those national or those global recommendations, or maybe not $400 a ton, but on average, but maybe $300 a ton on average, really going up over time to those higher numbers of the price of carbon, we could actually make this price difference between electricity and gas a lot smaller. And that's really important, because what we want to do is we want to switch away from using natural gas to do so much of our heating. And instead, we want to start using cleaner electricity. And I'll explain that. This price really matters a lot, and it's going to make a difference to people's decisions. The province isn't as committed to taking significant action, at least not right now. They were in the previous government, but right now there's sort of a wait and see approach. They're dealing obviously with a lot of other things, COVID and other challenges. So no slam on them for not having made any super strong commitments, but they're focused a little more on climate resilience. So that's that planning for when climate change happens. But the history provincially is that, wow, we've done a lot actually in Ontario to reduce our emissions. This is probably one of my favorite graphs, because it shows something really important about how to take action on climate change, and that's getting rid of fossil fuels in electricity. So you can see in Ontario, we were way up here. We were 250 grams of carbon per unit of energy per kilowatt hour. And we did a lot of work to decarbonize, get rid of the greenhouse gases, especially coal. We phased out coal. We stopped burning coal in all of our electricity use, and we got down all the way down here recently to almost a tenth, to a tenth of what we were over a 10-year period. So that 10-year, 90% reduction in emissions from our electricity use is a very important, and probably one of the most important things anyone has done in North America to reduce greenhouse gas emissions. So the previous provincial government is, in theory, credited and deserves credit for having taken that action to get coal out of our electricity system. Now, the problem is we're going to start phasing out nuclear reactors, and so we're not really sure where the emissions are going to go now, but they're not going to get all the way back up to this 250. Ontario, this is all the provinces now and how we all compare to each other in terms of our emissions. Ontario, for its electricity, is now down in the best performers down here. All the provinces that have lots of hydro and can make a lot of clean electricity. That's where they are. We're in that group now, which is great. We might go back up a little bit, but we're not going to be, part of the sort of dirty electricity folks. And this is, Alberta, Saskatchewan, Nova Scotia. These amounts of emissions from electricity are similar to what they are in the US, actually. So In the US, they have a big problem already. They have to get rid of a lot of coal from their electricity generation too, the way that Ontario did. And so Ontario is actually a beacon. It's a good place to look at, well, what's next after we get rid of the coal from our electricity? What are the other big things that we need to do? And that's where zero carbon buildings make a big difference. So, and you probably know that there are a lot of municipal commitments too. So our municipalities are starting to say, hey, we're in a bit of a climate emergency. We need to take action ourselves at the municipal level. And a lot of infrastructure dollars flow to municipalities for transit, especially, but also their building codes are regulated by municipalities. They're the ones who actually review buildings, and planning requirements exist at the municipal level. So what you're allowed to build and not allowed to build in many ways is governed by municipal rules. Although, there's a lot that is, exists between the province and the municipality that is more under provincial control. But it's great. Municipalities have been the leaders across Canada in setting ambitious targets and really trying to take action. And Waterloo Region is among those. So they've now set an 80% by 2050 target with interim targets along the way. Not the net zero target that is kind of needed or Greta would ask us to set, but getting there. And if you're interested, you can read. It's just released and I think approved by council. I don't 100% know if it got approved, but close to approval. This Transform Waterloo Region report. If you just Google that Transform WR, you'll learn a little bit about the kinds of commitments that we're trying to make as a municipality. This is an example of Toronto's climate emergency declaration. So they basically said, hey, we are in a climate emergency. We want to stick to this. And you can see, I'm sort of zooming in here, but we want to make sure we stay below the 1.5 degrees. That's a problem. We got to do a lot of work. Basically, that's what it says. And at the same time as we're doing that work, hey, let's try and invest in areas where we can really see building retrofits and transportation right away. Let's start to accelerate what we're investing in. That's when you're in an emergency, you start to accelerate that cycle of check and invest and check and act, and that sort of evolution starts to go faster. We want to make sure that there's financing to make sure everyone has enough money to do what we know is a tough thing to do. Appropriate financing. We want to, again, accelerate implementation of actions at every opportunity. So we want to look everywhere for where we can make change. And we know that jobs will come from this work. So we want to engage job seekers, workers, unions, institutions, relevant sectors, social services in the creation of low carbon job strategy. So Toronto sees it, and a lot of other people see it, as an opportunity to grow an industry, not just as an opportunity, as something you have to spend money on and you're reducing, but also you're increasing this green economy. And that's what a lot of these climate emergency declarations go. And if you look at Transform WR, you'll see it's a lot about what the opportunities are just as much as reducing emissions. So Toronto's greenhouse gas profile looks kind of like this. It helps to understand. I use a lot of Toronto examples because I do a lot of work in Toronto or for the Toronto folks. But it's interesting compared to Waterloo Region. You can see, half of it in Toronto is from buildings, the other half is from transportation and waste. And it's in Waterloo Region, half is from transportation, and then the other half is from buildings and waste. So, and agriculture actually plays in not a zero amount here. So we have a lot more agriculture and agricultural emissions. Toronto doesn't have very much of that. So, we have that, but it's this sort of half from transportation, half from buildings is, more or less half from buildings, is a similar ratio across a lot of municipalities that are in Ontario. So, and what about the buildings part? So a lot of it is from, you can see a lot of it is from residential. So multi-unit residential buildings. In Toronto, there's a lot of those. There's also a lot of single family homes. In our region, a lot more single family homes, but the amount of residential is probably pretty similar. Industrial, about, maybe 15%, and then the rest of the buildings. So, universities and other commercial buildings, office buildings, they're, about a third or so. And you can see this here, this is what I was sort of saying before. Emissions from electricity, because of how clean Ontario's grid is, are very low. It's all the natural gas that we're burning that is the main source of our emissions, from buildings at least. So not getting rid of natural gas burning is actually the main problem when it comes to zero carbon. It's a good example of a policy that was developed by Toronto. So they identified this problem, they went through a first iteration, they looked at it, they came up with some ideas, and they developed what's called the Toronto Green Standard. And so it sets targets for energy and emissions for all new buildings. There are also climate resilience requirements. So you have to think about the impacts of climate change, make sure, there's cooling in buildings that are going to, struggle to stay cool in heat waves is an example. What happens if the power goes out? That's one of the questions they ask. And that's a climate resilience question because storms are more frequent when climate change becomes more severe, and that can knock the power out, or there's an ice storm or other things, right? So, and then they also have probably the most important feature of this Toronto Green Standard is that it sets tiered performance, which means right now it's not that hard, but the next time you build, it will be harder. And if you go to that next level of performance, we'll give you some a reduction in your costs. So there's an incentive to try and be that next level of performance. And they're just about to release a new version where they ratchet down that performance. So what is the next level now will become the minimum performance next year. And so there's this ratcheting down effect. And I'll show you a little bit about that in a second. The other big thing is that, as I was mentioning, there's a lot of opportunities through federal dollars flowing to these incentive programs, one of which is delivered by the Federation of Canadian Municipalities. And they don't just pay for people to do the work, they also pay for them to study what it takes to do more, because it's not a straightforward problem. Anyway, suffice to say, those are sort of the conditions that are out there. There's lots of municipal targets, there's a lot of federal money. Federally, we're really committed to this problem, and increasingly at municipal level, there are lots of strong drivers, and there's lots of money flowing to address the problem. So I'll stop there and see if there are any questions. I'm going to talk a little bit about these metrics and then a little bit about solutions, but I'm going to go a little bit faster here because I do want to sort of give time for questions. I think you said, Jill, we have till sort of the hour, right? Another half hour or so, but I'm going to try and go quickly through the rest of the presentation. So.
I have a question. I know
Sure.
you knew it. I noticed that Quebec is really, how come they have almost the same number of people as Ontario, and yet they're so low. They're like one of the in the electric grid carbon intensity. What are they doing?
Well, yeah, if you've ever been to Quebec, you might know they have a lot of rivers. They also have the biggest river in Canada that flows through their province. I guess it's a seaway technically, not a river. But in Quebec, hydropower makes up over 2/3 of all the electricity that they generate. So hydropower is very low carbon, doesn't take, you don't have to burn anything to generate hydroelectricity. And so for that reason, they have a surplus. And in fact, a lot of discussion has gone on about Ontario buying Quebec power to not just to make it less carbon intensive if we want to keep, if we want to avoid increasing emissions, but actually just because it's cheaper than our current power. So it's a good question though. All right, I'll keep going. So I talked about that Toronto Green Standard. I just want to quickly show that it's not just Toronto that has these tiered performance requirements. So right now you have to be up here. I mean, the numbers don't quite matter that much, so you don't have to invest a lot of time. I'm going to talk a little bit about the zero carbon building standard. It's kind of down here right now. So maybe half of the current standard. But right now, or very soon, jurisdictions all across Canada are going to need to meet this first ratchet down in performance of new buildings. So we've gone from somewhere around here in Toronto. Now, like I said, next year, Toronto's going to go to this level. So maybe about 25% reduction in what the energy use is allowed to be. And you can see that in BC, they're already there. They have the step code in BC. It's very similar to what Toronto has. And the new on the national building code is also starting. It's going to have a new tiered approach that's borrowing from what they did in Toronto and BC, where they're going to have to ratchet down their performance. So that's where we're going to be very soon. This new one, this is an example for office buildings, but there's requirements for residential buildings as well. And then sometime in the middle of the 2020s, we're going to ratchet down one more time. And then by 2030, we're going to be at this basically as good as you can get level of energy use. It's really hard to go below this number just because of physics, to be honest. So, we're going to get to about half or maybe almost a 2/3 reduction. Exactly that number that Greta was hoping that we could achieve in terms of energy use in our new buildings. I put this up here just as a beacon of hope. So this is a project that we worked on for the Ontario Architecture Association. This isn't a new building. This is actually an existing building that was retrofitted, and it achieves even lower performance than all of these other projected regulations for buildings. So meaning that you can get to below the regulation if you just want to, right? And that the Ontario Architecture Association wanted to. They wanted to build a really low energy building. And actually, another important thing is that if you install electricity generation, so you put up what's called photovoltaic, or sometimes called PV panels, solar panels, they call them. If you put those on this building, which uses very little energy, you can actually be in a surplus of energy use over the year. So now we're at that net zero level of performance. And that's what net zero means. In many ways, it's that you make as much, or you sequester as much, or you store as much as you use over the course of the year. So this is a first net zero example, this OAA building, and just as a graph, right? Like seeing how it compares to what the current laws are going to be over the next 10 years. So, but it's not just, it's not just about how much energy we use, it's also about the grid and about where you get your energy from. So those two things together make up what we need to know in order to understand if we're net zero carbon, because the carbon emissions come from what fuel is burned to make that energy. So if you're burning natural gas, it's higher. If you're burning electricity, if you're using nuclear or hydro, you're making energy for yourself that is lower carbon. So that's a really important part. So net zero carbon operational is also about the source of the energy. I'm going to skip this one just in the interest of time, but it's suffice to say the federal government has done the best job to help think about this idea of zero carbon. And remember, we talked about how on the grid, it's going to start going up over time. The important thing to know is that electricity itself isn't zero carbon. It isn't, if you just use electricity from our grid. You might hear people say, oh, Ontario has nearly zero carbon electricity. Well, it's not zero. So if we want it to be zero, we actually have to choose to buy renewable electricity, which is generated either from solar panels or wind or other renewable sources. So there's actually a choice to be made, even at the end, once you've done the best job of making the building more energy efficient. The other thing that's true is that given how complex our grid is, people asking for, maybe we're generating solar over here and wind, but there's a lot of city demand, and we're starting to store electricity over here, but we've got these high voltage lines anyways. And there's a big wind installation over here. It's starting to become very complex, this grid of power. Some of it's local, some of it's a new wind farm. So the utility operators have a big problem to deal with all of these new technologies that are coming on to quote unquote generate renewable energy, or to, maybe they're just because people are spending too much money on electricity and it's costing a lot of money. So they want to reduce those costs. This complexity is only going to be harder as we start to try and do more to reduce our greenhouse gas emissions, because the easy thing to do is to use that low carbon electricity. But that's going to start increasing the demand for that electricity. Now, if we think about things more holistically, and this is what zero carbon buildings really are, just to take this example of an office building, built to typical standards, in the summer, it needs 228 kilowatts. So that's how much electricity it needs. That's how much power needs to be ready for that building to work. If we think zero carbon, we can bring that summer amount down quite a bit. Now, we did increase the amount we need in the winter a little bit, because now we're using electricity to make heat. But it's kind of pretty balanced out, like in 131 in the summer and the winter means that now the utilities have a very even amount of power that they need to be providing to this building. And the more even the power demand is, the better. And so zero carbon isn't just about, actually how much electricity you need or how much gas you need. It's also about working with the people who plan the grid and trying to balance out, making sure that power that grid electricity isn't going to become more carbon intensive. We're going to burn more natural gas. So there's this interplay there, and that's important to the future and how incentives will flow and who's responsible for what in terms of this bigger carbon problem. I'm just going to skip ahead. So another really important thing is that idea we talked about, that upfront, or let's call it embodied emissions, or the emissions associated with building materials and with manufacturing of materials for buildings. So the operational part, how much we use when we're in the building and it's heating and cooling us and lighting us, that's this, say 28% of global emissions. But there's another 21% here of all of the emissions globally that is part of the manufacturing. Now over here, we've got all of our emissions from driving around and all of the other emissions. So, half of the emissions, again, can be seen as coming from buildings. I'm going to just credit my friend Chris Magwood from the Endeavour Center. He's one of the leaders in Ontario and in Canada talking about this sort of embodied carbon, or the emissions that come up front before we even start to use the building. And this is the last little bit that I really want to dive into so you can understand this sort of primer. And then I'll stop and I'll ask some more questions. And I think that can be it for today, but I want to give you a bit of a story that Chris tells. So we're doing a pretty good job of this building operational emissions, but it's these embodied emissions that we tend to be ignoring, or we don't think too much about. And I think that's Chris sort of says, well, hey, there's about half the problem that we're ignoring there when it comes to buildings. So we want to think about these embodied emissions, the ones that come from extracting materials and transporting them and then manufacturing them and getting them to site. We call that cradle to gate. So the emissions from wherever in the cradle of the earth we draw these things that we use in our buildings, and then to the gate of our site where they then get assembled and become our building, right? This is the cradle to gate emissions. And that part of the emissions for most of the materials in our building can be, as much as 90% of their whole life cycle emissions as materials. So a lot of it happens in that first part as we make, transport, and manufacture, extract, transport, and manufacture. The thing that Chris has really spent a lot of time helping us understand is that it's not just the emissions that come from that process that we're not thinking about. It's also the ones that could come by drawing down greenhouse gases into living things and then storing those living things in our buildings. They call it biogenic materials. So wood, switchgrass from straw, and Chris is famous actually. He's the straw bale guy. So that's where he kind of comes at this thinking. But if carbon is being drawn into the wood and the other products that we make our building materials out of, then we could store those products for a really meaningful period of time as insulation or as structure in our buildings. And that allows us to do that thing that those global thinkers were saying, well, hey, what are these innovative storage or carbon sequestering mechanisms that we can find? So if we draw it down into the trees, yeah, maybe there'll be some emissions that come from manufacturing those trees and those switch grasses and those straw bales, but we're still stored a bunch of it. So you can see it's not the whole drawdown that we then release as we manufacture those products. So there's net carbon storage in all of this stuff. And again, Chris made an awesome graph. So if you think about it, when you plant the stuff, that planting takes some emissions, but then photosynthesis draws all those emissions down. And then you harvest it and you make it into straw bale insulation, you take it to site and you build the straw bale building. But then for the entire lifespan of that wall of that building, as long as it sits up, it's stored in that building. And then at the end of life, well, if you reuse that straw bale, great. You didn't actually create that many more emissions. If you recycled it, well, maybe a few more. If you turn it into biochar or trying to do other cool things with it, that might take more energy, but still stored. You could burn it, you could landfill it, and then you're kind of back to zero. But you could let it become methane. That's an option. So that would be an emission. That might not be good. However, for typical materials, we just, virgin forest, we just harvest it, make it into, or not virgin forest, or like steel, we just harvest it, we manufacture it, transport it, construct it, And over the whole building lifespan, that was a net positive emission. So that was, we weren't really we didn't have this drawdown benefit that comes from using natural materials. And at the end of life, whether you landfill it or recycle it, you're still in the positive. Whereas, the drawdown benefit here is pretty important. And I think that's one of those ideas that is new that I think Bob has really integrated in his design for the To Thrive Together facility that is not that common to think about. And it's starting to become very important. So, and I'll just sort of summarize this. I'll sort of encapsulates all these ideas that I've brought to the table. So there's what we call the upfront emissions of a typical building. And then over time, say leading up to 2050, that critical period, this graph is not going in the right direction. Greta does not like this shape of this curve, right? There's a big bump up front, and then we just keep going up. We're burning that natural gas. Now, if we think about just how much we use in terms of electricity, and we start to really reduce, switch away from burning natural gas, we use electricity, and then we generate some electricity on site, or we buy renewable energy, if that's the renewable electricity from the right people, we can really flatten out this part of the curve, but we still have those upfront emissions to worry about, maybe, but, if you start from that perspective and then you say to yourself, well, could we get actually below, could we create a carbon positive situation and really see that curve going down over time? And so if we focus on reducing the upfront emissions, the things that Bob's done could actually put these upfront emissions in the negative to start. And then if we continue down by generating and storing, and you're really being thoughtful about when we put carbon back on the grid, really thinking about the grid and storing things and generating renewable electricity on site, wow, we can actually be in a net negative situation. And now we're helping other buildings that, existing buildings that can't work as hard as this new building can to really reduce emissions. That's the potential of zero carbon. That's really what is at stake and what we can do. And that's sort of, they call it sort of flipping the script from, not something that is really productive, is adding to the problem to something that allows us to really, contribute to reversing the problem. So, and what does it take? Well, I have more to say about that, but I don't have a lot of time, so I'm not going to spend that time today. But, in typical buildings, we make sure that the building walls and roof are good. We make sure that the HVAC systems, how we generate heating and cooling and the ventilation, is efficient. But then we try and keep it low cost. And if we're trying to operate zero carbon, well, we need to do that fuel switching away from natural gas, and we need to try and generate electricity on site. And if we really want that maximum site potential, we're doing all of those things, but we're also looking at the embodied carbon choices that we make. And that lets us be in this negative situation. So I can tell you a lot more about all of those choices and how to get there, but I don't know that I have time. So I'm happy to entertain that discussion, but this is really the primer, the sort of first stage about thinking about carbon and how we make those choices. So I'll pause there and offer a chance for questions.
I had a couple of questions there.
Okay, go for it.
So we came across this interesting proposal from a new upstart company in Vancouver that wants to store the energy, the excess energy that we produce, in batteries. What about, does that make sense as opposed to feeding it back into the grid? Because if we feed into the grid, I think, well, if we're feeding into the grid at peak times, that's a benefit to everybody. What's your take on that?
Yeah, I mean, the battery is an extra cost, it's extra maintenance. And the question is, does it help you to be more optimal in when you put energy back on the grid? And it does, right? So a battery lets you store electricity that is being generated during the day when the sun is highest in the sky. And it lets you shift that electricity to the time when the demand is the greatest. So in the summer, actually the peak demand in the summer is usually around 5 o'clock or 6 o'clock, when people are still in their office buildings and none of that demand for electricity has really shut down. The sun is still the sun has made that building hot over the course of the day, and so we still need to air condition it. But then everybody comes home, or half the people come home, and their air conditioners turn on because they come into their house, and so everyone's air conditioner is running. So if we can but the sun is shining the brightest at noon, right? And that's when you generate the most solar power. So if you could just shift that over into the time when it's the worst in the day, that's the benefit of the battery. It's that allows that short-term shift of your generation into the time. And so you can actually optimize, but that's the summer. If you're using heat pumps, you're also using electricity in the winter. So if you can store that sun in the day and then use it at night to power your heat pump, that's also an opportunity, right? Something that is important to consider. And in the future, in Ontario, if we all switch over to heat pumps, well, actually now the time of the year when grid planners are going to worry about the most isn't in the middle of the summer when it's hottest. It'll be in the middle of the winter when it's coldest. And so there's going to be that's why that diagram with all of those grid implications is so important, because that problem is a very systemic problem, a very tough one to solve. And we can solve it on site and make it easier for grid planners with batteries and other technology, then we can help. Now the problem, the situation with batteries is that there isn't anyone really thinking hard about how to solve that problem yet. We just know it's going to be a problem. Even in Ontario, especially, like the system operator is like, well, yes, we definitely know there's going to be issues, but we're really not sure how we're going to solve this problem yet. Like, it's not like they've developed a whole bunch of great programs or solutions the way that, other efforts have been made by, say, the feds to just get people to start thinking about carbon in general. So I think that's like a few years away before the grid operator is going to be like, yeah, we really should be incenting batteries because we're really going to be stuck here in the long run. But you'll see that. I'm sure it'll come. It's unobvious. So you're kind of ahead of the curve by buying the batteries now, and there isn't a lot. You'll be on the bleeding edge because there's not a lot to pay back and help incent that yet, unfortunately.
What I loved about this company, it's Moment Energy. They just won a big design or a big
I've heard about them. That's great. Yeah.
And a really nice group of young. I want to say they're kids because they all look so young. Like they look like they're 12 or 15, right? But their brains are definitely going. But they're recycling batteries out of electric vehicles. So at the end of the life of the electric vehicle, they're recycling that battery into home energy storage.
Oh, that's great. And if they
Which
can
is
make
very
it
cool.
cheaper, if they can make it cheaper by doing that and like have a way of bringing new life to because the car batteries are really sophisticated. The home ones don't need to be nearly. So that's a really smart way of doing it, for sure.
I think that most car batteries get traded out at 80% efficiency, which he says is like, that's plenty for what we're doing, right?
Yeah, the car design requirements are a lot more strict than the home ones, for sure. So that's a genius. And it's that kind of thing that's going to come, right? Yeah, it's that kind of thing that's going to come as research dollars and flow to these design solutions. That those are the kinds of opportunities that are going to flow to, for sure. So.
Wow, my mind is just going here. That was great. For me, it took really some really difficult concepts that seem to be not connected, and you filled in the connections for me. There were things that I hadn't actually seen before as being related to one another. So that was great. Thank you. Really well done talk. Thanks. And whew, I don't know about the rest of you, but my mind is going here. That was great, Antoni. Thank you. You managed to take those concepts that are somewhat difficult for us in the lay world to understand and put them together in a format that we could see all those interrelationships, which is really important. You want to see the big picture. Anyhow, thank you. That was such a fun way. Take 3. Wow. My brain is just spinning here. That was great, Antoni. Thank you so much. You managed to take a lot of difficult concepts and not just explain them in a way that was understandable, but the relationship between all of them. And I think that is really important. For those of you who are interested in the To Thrive Together Sustainable Living concept and our pilot project in Bloomingdale, if you have any questions, do write to me. The address is info@tothrivetogether.org. Not .com, .org, info@tothrivetogether.org. If you have questions for Antoni, I would be happy to relay them to him. Our time is up. Thank you so much again, Antoni. You have been a wealth of knowledge this evening, and I don't know what To Thrive Together would do without you. And thank you to WSP for allowing you to share your presentation and your knowledge with us tonight. Stay safe, everyone, and we'll see you at our next gathering. Good night.